Hi, welcome back to AWS Innovate. You are currently logged into the Big Data and Analytics track. In this track, we are covering topics around big data analytics, data lakes, machine learning, and artificial intelligence. I hope you are finding this track useful and are able to relate to the use cases and requirements in your organizations. In this session, we will look into how to build data pipelines with AWS Glue. My name is Uni Pillai, and I'm a solutions architect with Amazon Web Services. On a day-to-day basis, I work with customers across Asia to help them build their analytics platforms and data lakes on AWS. And today, I have the honor of having one of my customers join us to share how they build their data pipelines using AWS Glue. In this session, I will give you a quick introduction to AWS Glue and share why did we create the service. We will take a look at the different components of AWS Glue and understand some of the key features that Glue provides. We will dive into how do you construct an ETL workflow in Glue, all the way from taking raw unfiltered data to building a data pipeline in 4 easy steps. I'm going to dive into the AWS console and actually build this out for you and show you how it is done. In the latter part of this talk, I will have Mr. Thanomsak from NEXTY Electronics Thailand office, which is part of the Toyota Tsusho Group, to join us today and share his story with us as well. So what is Glue? Glue is a fully managed serverless extract, transform, and load service, also called ETL for short. Now there are plenty of ETL tools out there, but Glue is one of those that are designed for developers and designed by developers. We have thousands of developers on our platform who are running thousands and thousands of jobs on a day-to-day basis. In our ecosystem in AWS, we actually have a number of partners who do ETL. There are many tools already available to customers. Here are some of the ETL tools that are listed on the AWS Redshift partner page. But it turns out that there are a lot of AWS customers who are developing their ETL scripts by hand. That is actually hand coding their ETL jobs. This is the very reason why we built Glue in AWS. Because most of the tools that I showed you in the previous slide does one thing that one thing extremely well. But your ETL job in your company isn't just about that one thing. And when you want to go beyond that one thing, you will have to end up having to build your own ETL jobs. And that is when you start coding your ETL jobs by hand. But code is powerful and flexible. There are a lot of things that you can do with code with very less limitations. But code is modular, and you can actually build it in the way you want it. You can share it with your team members using Git or other source control management tools that you and your company uses. And more importantly, your organization already has a bunch of developers who know how to deal with code. They are building your applications for you. They have the existing dev pipeline in place used for developing and managing your application code. So why not use the same to develop and manage your ETL scripts and your ETL jobs? There are familiar tools out there, IDEs for developing and debugging. You have got version control for tracking changes. You have got the testing pipeline and continuous integration and deployment pipelines, and so on. Even though everybody is coding, doesn't mean coding is easy. In particularly, writing ETL job is especially hard. The reason it's hard is because the underlying data is changing. The underlying data schemas are changing, and the data formats keep changing as well. In an agile environment, you need to add or remove data sources that have, and most importantly, the data keeps growing, and it grows pretty fast. What this means for developers is you have to constantly change and to adopt the scripts, which makes hand coding ETL jobs especially error-prone and brittle. That's why we created AWS Glue. It actually does a lot of the undifferentiated heavy lifting that you need to do to manage these changes so that developers can focus on the high-level things that they need to get done for their ETL code. We do the rest underneath. Let me walk you through the 3 main components of AWS Glue. First, we have the data catalog. This is where all the metadata about your data set sits. Second component is the job authoring and ETL system, which you use to write your ETL jobs. The third component is the one which provides you the job execution framework in a serverless manner. You write your ETL code and give us the code. We execute it for you. As a developer, you need not worry about the underlying infrastructure and worry about provisioning those servers. Glue Catalog is a Hive-compatible metastore, which means that you can integrate with a lot of other tools, including other AWS analytics services like EMR, Athena, and Redshift Spectrum. Glue crawlers can automatically discover your data, infer the schema, and store the details in Glue Catalog. Glue Catalog makes it easy for data engineers and developers to quickly search and locate your data and use it for rewriting your ETL scripts without having to manually keep track of the schema and data formats. It also has information on statistics of your data lake, how big the data is, and how many records do you have, what are the other partition information, and so forth. The first thing that you do is it lets you get started quickly with the ETL flow. It generates code for you if you point it to a table inside the data catalog. It generates code in Scala or Python. It works with Apache Spark in the backend. So it's an environment that many of the data engineers and developers are already familiar with. Then we offer tools that allow you to edit, debug your code, and explore your data sets that you want to analyze. We also have new and interesting primitives that make it easy for you to rewrite your ETL jobs. Glue ETL jobs can be executed on demand or run on a fixed schedule like a cron job. It can also be triggered based on when a particular trigger condition is met. Throughout this talk, I'll be using an example and use case where we'll be converting some JSON data to Parquet format. It's a typical process that you follow when building a data lake and working with data warehouses. Here is what we are going to do. We are going to work with GitHub Archive data. To put it simply, it's an archive of all the events that happen in the public GitHub repos, which GitHub makes it available to the public on an hourly basis. You can go to their website and download these files. First, we will find a way to ingest the data into the pipeline. In this case, we will be manually downloading the files from GitHub Archive and putting it into an S3 bucket. Second, we will run the Glue crawler on the data sitting in S3. The crawler will infer the schema, generate the statistics, and create the tables in the Glue catalog. Third, we will author a new Glue job using Glue's inbuilt code editor to convert your JSON files to Parquet format and store it back in S3. Once the process and the transform files are available in S3, they can be consumed by a variety of analytics services to run queries over. In this example, we will be using Athena to query the data and QuickSight to visualize it. As I said earlier, AWS Glue is backed by Apache Spark, which is a distributed, parallel, and scalable data processing engine that has got fault tolerance inbuilt. So if things fail, it can take care of it and you don't have to worry about it as a developer. With Spark, you can not only write scripts, but you can also write SQL with Spark. You can intermingle these things freely, so it's quite flexible to use. Apache Spark has a very rich ecosystem and very strong community support. Many companies are running it for all the way from processing the data streams to doing graph analytics to building machine learning models using Spark ML libs. Core of Spark, what they have is that it's a structure called RDDs. They have basically resilient distributed data sets. On top of RDDs, you have a data structure called data frames. It provides you the structure that lets you run your transformations. When using Glue, in addition to the Spark data frames, you have access to Glue's ETL libraries. These libraries allow you to integrate with all the other Glue components like data catalog, job orchestration, and bookmarks for checkpointing, and maintenance of the state of your job execution. Glue libraries also allow you to integrate with other AWS services like S3 and RDS. As a part of the Glue ETL libraries, we also have shipped some really cool ETL transforms, connectors, and format supports, which would require a lot of manual effort from you if you had to do it on your own. Next, I want to introduce the concept of a dynamic data frame. But before, let's take a look at the GitHub Data Archive datasets and what are we dealing with. So this is the GitHub Archive dataset. The data sits in JSON format. There are more than 35 different types of events that are present in this dataset. If you look at the image on the screen, you can see that there is a different type of event, and each different type of event has its own payload, and each payload has its own structure and size. This particularly makes it difficult to process and use this data. Now let's take a look at how Glue helps us in this situation. Data frames are the core structures for Spark SQL. They are like structured tables in the database system. You kind of need them to have the schema defined upfront. Each row in the data frame has the same structure. So what this means is, if you are trying to load the data and you don't know the schema of your data upfront, Spark has to first read all the data and compute the schema. If you're working with structured data, that looks tabular. This makes sense if you want to do SQL-like analytics. But for doing that and working on ETL for unstructured data, it's not quite ideal. This is the reason why we designed dynamic data frames in AWS Glue. It has relaxed some of the assumptions about having the schema upfront and having the same structure per row. They are like data frames, but designed for ETL. They are designed for processing semi-structured data. What that means is, if you take an example that I showed you earlier for public GitHub Archive events, you have a lot of different event types, and payload structures varies for each event. Every dynamic frame is a collection of individual records called dynamic records. Dynamic records are self-describing, so you don't actually need to have schema stored up front at the dynamic frame level. Each record individually stores its own schema, so it can vary from record to record. What this means is, it's really easy to run transformations on semi-structured data. If you notice here, in our create event, pull event, that is the first and the third dynamic record on the screen, the data type for our ID fields are different. The first one is string, while the other one is an integer. If you use it with Spark data frames, it will read whatever it is there, and it will convert it into whatever it thinks it should convert it into. But Glue dynamic data frames doesn't do that. They are self-describing. We keep that intact, and when you at the later stage can decide what you want to do with it. So in the dynamic frame, here at the bottom left side of the screen, you can see that there are two different versions of the ID. One that is integer and the other one that is string. These features provide dynamic frames, make it easier for us to transform and run transformations on it. Let's take a look at some of the inbuilt transforms that Glue comes with. With dynamic data frames, you can perform over 15 transforms. One of the simplest things that you can do is to decide how do you want to resolve your choices between integers or string. Another transform that Glue supports is called apply mappings. This will allow you to take structured, semi-structured, or nested JSON data and flatten it in any way that you want, and pick up the columns that you want and rename them. You can also go from a flat structure to a nested structure. One of the most sophisticated and interesting transforms available in Glue is called Relational Eyes. It takes in any arbitrary schema that you have in a semi-structured form and turns it into a collection of tables and columns. The resulting set of the dynamic frames can then be loaded into a serving layer of the data lake, either by dumping them into S3 in Parquet format or loaded into a data warehouse like Amazon Redshift without having to worry about the semi-structured nature of the data. It basically creates a column for every path from the root to the leaf. And for every array, it separates it out into an auxiliary table. This auxiliary table will have multiple elements for that array, and it will join back up with the original table using the primary foreign key relationship. The real power of the relationalized transform is that it allows you to process semi-structured data in Glue and then normalize the data set into individual tables in Redshift. This is far more efficient than storing raw JSON data in Redshift, as it is optimized for faster reads from a columnar data format. This makes your SQL queries can go orders of magnitude faster if you were just to natively process JSON data. These are some of the other transforms available in Glue. 2DF. This transform converts the Glue dynamic data frame to a Spark data frame. It is useful in situations where Glue doesn't have a transform that you want to run and you would like to run your own transforms on it. Spigot. This transform will dump samples of your data sets running in your pipeline into S3 so that you can debug your code and see the pipeline is spitting out data that is in the desired format. Join. Helps you join two dynamic data frames and gives you the combined dynamic data frame. There are a bunch of other transforms as well, and they are well documented on our website. All right, it's time for the demo. Let's quickly take a look at what are we going to do during the demo. I'm going to build out a pipeline using Glue in 4 easy steps. I will ingest the data into S3. In this step, I will do download the data from GitHub and put it in the S3 raw folder. Then I will create a Glue crawler to discover and catalog my data. Once the crawler has done its job, I will create a Glue job to transform my JSON data into Parquet format. Once the Glue job is finished transforming files, it will be available in S3 buckets process data folder. From there on, I'll be able to access the process data using Athena and will be able to visualize it using tools like QuickSight. Now, let's switch to the demo screen. I will log into my AWS console and show you how to build a pipeline in AWS Glue. So here we are in my AWS console and in my S3 bucket. So this is the S3 bucket that we'll be using and working with this demo. So here I'm creating a new folder to store our source data. Then I will download the files from the GitHub Archive and upload it into my S3 bucket. So let's see how that is done. Right, so now I will upload the file. It's going to take a couple of seconds for the file to get uploaded. Now that the file is uploaded, we'll go to the AWS Glue console and create a crawler there. So let's open the AWS console. So this is how the AWS console looks. On the left-hand side, I'll click on the crawlers and I will create a new crawler. I'll specify a name for the crawler and click Next. Here I'm specifying where the source data is kept. So in this case, it is in my Innovate Glue demo bucket. So here I've specified the source bucket, and here I'm specifying the IAM role that the crawler will be using to crawl my data in S3. Here I'm adding a new database in the Glue catalog by saying calling it InnovateDB. I'm reviewing the changes and click on Finish. Now we will run the crawler and wait for a couple of seconds for the crawler to finish. You can see that there will be one table that will be added to the crawler. And now if you go to the catalog, click on the database and look at the tables, there is a new table created called data. And it has this data structure that we for the data that we imported from GitHub Archive. Next, we will create a new job in Glue. I'm specifying a new job, a new name for my Glue job, specifying an IAM role and choosing Python as a language. Here I'm specifying the source data set, specifying the target data set. So in this case, it will be an S3 folder called process data. I'm also specifying the format of the file to be Parquet. Here in this screen, I'm specifying the mappings from my source data set to my target data set. And I'll be adding and removing some of the fields that I'm interested in. So in this case, you can see that I'm interested only in the repo name. So I'll be mapping the repo name. And the second field that I'm interested in is the actor field. So I'll be mapping the repo name to repo and the actor name, that is the login ID, to actor on the right-hand side. Once this is done, I'll be saving the job, and it gives me the editor for Glue jobs. Here you can see that there is a source system. I'm applying the mappings. I'm resolving some of the choices, and dropping the fields. In the last sentence, I'm actually taking the data frame and dumping it into S3, creating a sink. On the left-hand side, you can see that Glue has generated a diagram of what my code is doing. Now, once the job is successfully run, I can go back to my S3 console and look for the new folder that has been created. So here under data, I have my processed directory that has been created. Next, we will go to AWS Glue, run the crawler again. Once the crawler runs, you will see that on the right-hand side, it adds 2 tables. The 2 tables added here are processed and raw. So if you look at the schema, it is the schema that we specified during the mappings. Now we are in Athena, and in Athena, I'm specifying the query that I need to run. So in this case, it is looking for actors, repos, and the count of how many times a particular actor has acted on the repo. Yeah. Now let's go to QuickSight and visualize this data that we have just processed. Now we go to QuickSight and create a new data set. We will choose Athena as the source and put in the required details here. For simplicity, we will just choose one table here. So I'm choosing the process table. And I'm going to tell QuickSight to access the data directly from Athena. Here, for simplicity, I'm going to use only a tree map and look at the repo. So as you can see, 50% of the events in our data set are push events, followed by create events and so forth. So this was a quick demo of how you can take raw data from GitHub Archive website, putting it in S3, discovering the data and cataloging it using Glue, and then converting the data to Parquet format so that you can visualize the data using QuickSight and Athena. If you wish to recreate the steps that we did during the demo, you can follow the URL or scan the QR code on the screen. It will give you the step-by-step instructions on how to build out the whole environment in your own AWS account. Now, I would like to invite Thanomsak from NEXTY Electronics to share their story and how did they build a data lake on AWS.
Hello, my name is Thanomsak Ajjanapanya. I'm a group manager content department of Toyota Tsusho NEXTY Electronics Thailand. Today, I would like to share you about our journey on building AWS data lake and how we build our processing pipeline to process our traffic information statistic data. Before going into detail, let me share a bit more about our company and what we do. We have started content business in 2011. We have been collecting GPS data, incident data, and various sensor data, and providing the traffic information service for automotive industry in Thailand. Now, we are expanding into data analysis business and providing the platform solution for logistics, parking, and healthcare. We are using GPS data as the main data source, which is collected from about the 140,000 vehicles using onboard electronics. Every day, on an average, we are getting about 100 million data points, which about to 3 billion data per month, collected from more than 100,000 load links across Thailand. Our challenge is to build the model to predict the speed and traveling time for all load links in Thailand. In the past, we store all our GPS data on flat file storage system. And when to do a machine learning task, we had worked on preparing the data for presentation, load our data, and transform to the format designed by our client. In the past, processing 1 month of data would need us to spend more than 6 hours doing ETL, which was waste time consuming and would be massive waste time for us. This is the reason why we decided to move to a data lake-based modern data architecture. So here is how our new data processing and data lake architecture look like. GPS data is pushed from the source system into the cloud using Kinesis Stream. Using Kinesis here, make sure that we don't have to manage our own streaming infrastructures. In case of amount of car on the load grow, we will be able to scale easily with Kinesis. Once the data land in Kinesis, we have a set of the Lambda function that dump the data into S3 in our raw data lake storage. Here, we run Glue caller to discover out data schema and then catalog it in Glue catalog. We use Glue ETL script to then convert the data in raw data bucket in packet format. Now, we have the data available in lead optimized columnar data format for consumption and further analysis. Further down the processing pipeline, we use Redshift, Athena, and QuickSight for data exploration and analytics. For the machine learning job, we consume the data directly from S3 and Redshift Spectrum into our Spark cluster. Here, we use Spark machine learning libraries to create traffic statistics and prediction. For real-time pipeline, we have Spark streaming application running that consume the data from Kinesis Stream and system that engage with customer in real time. Making data available for analytics has become much easier since we started implementing the data lake architecture. The architecture that I showed you in the last slide now enable us to analyze traffic incident, predicting parking requirement, and predicting traffic congestion across Thailand. These have had a very big impact and has strengthened our core data analysis business and how we serve our customer. That's all I want to share with you today. Hopefully you found it useful. Thanks for watching. You have a nice day ahead. I will hand you over to Uni.
Again, here is the link for the demo. You can recreate the demo by following the instructions provided in this guide. Finally, I'd like to thank you for attending this session today and sticking it out to the very end of the presentation. To gain more confidence and hands-on experience with AWS, you can access the digital and classroom trainings built and delivered by AWS experts. AWS also has a wide partner ecosystem to help you focus on your success and take advantage of all the business benefits that AWS has to offer. To learn more about the AWS partner ecosystem and find the right one that fits your needs, please visit the AWS partner booth at our showcase. Thank you very much.